Hello and welcome to this BOXER tutorial. In this video I'm going to show the workflow in setting up and generating a mesh using BOXER. I'm going to demonstrate how to produce a mesh for a cooled turbine blade geometry to show the workflow. The first step is to import your geometry. BOXER can import a wide range of CAD formats, and you can combine multiple geometries from different formats in BOXER. You can see here we have a cooled turbine blade. You can use the feature tree here on the left to toggle the view of the features. I can untick the disk pad to get a better view of the cooling holes. Once you have imported the geometry, we will move to the mesh setup phase. The first step is to set up a bounding box to define the extents of the mesh domain. Click the Edit Bounding Box, which can be found on the toolbar at the top. This can be Cartesian or cylindrical, and it can be defined using various methods. Here we're going to use fixed Y. This lets you set the number of background octree cells in the Y direction. By setting the mesh as Y periodic, we will ensure that the mesh is conformally node matched across the Y periodic faces. You set the two corners of the bounding box. This can be done in the graphical interface by moving the drag handles, or it can be typed in. We'll set 20 cells in the Y direction, and this sets a background length scale. Looking at the bounding box, you can see we're only going to be meshing a thin slice of the blade. Now you define the region or regions you wish to mesh. To do this, click Create New Region in the toolbar and place a seed point within the bounding box in the region you wish to mesh. We'll place a seed point in the fluid region. Again, this can be done in the graphical interface or typed in. If you wish to generate a solid fluid conjugate mesh, for example, then you would place another seed point in the solid region. Now you have defined where to mesh, you can specify the mesh refinement. BOXER's octree approach refines the mesh by subdividing the background cell. The background cell length scale was set during the bounding box setup earlier. And now we can set the regions where we want a higher mesh refinement. You can define the mesh refinement on edges, faces, or by volume. The background length scale is level 0. Level 3 would be 3 subdivisions of the background cell. You can define the region for this refinement by dragging and dropping the patch name from the feature tree on the left to the feature tree subset on the right. I did the same for the other patches, with a high refinement level for the internal passages. BOXER has a preview button, which displays cubes on the geometry, showing the current mesh specification. For fluid meshes, you will likely want to add near wall layer mesh. This can be done simply by clicking the Create New Layer specifier in the toolbar. Type in the number of near wall layer cells and expansion ratio. If the feature tree subset is left empty like here, it is automatically applied to all the patches in the mesh region. We can now go ahead and generate the layered mesh, but it can be a good idea to generate the octree first. The octree mesh is a hanging node tessellated mesh that sits off the geometry. It provides a fast representation of what your final mesh will look like. Here it took less than 10 seconds, and it can be used to check the mesh resolution before generating the final mesh. I'll now click Generate Layered Mesh. This generates the conformal body-fitted mesh and adds the near wall surface layers. I have skipped forward, but that took just under 7 minutes on my laptop, and we can now look at the mesh. You can see the body fitted mesh. I will use an ISO surface to view the mesh. The internal passages have been fully meshed. BOXER has flood filled the domain from the seed point we specified earlier. Zooming in, the higher mesh density at the internal passages can be observed, and the near wall layer mesh has been added to the surface. The last step is to export the generated mesh. Click Insert, Mesh Export, and choose your preferred export format. Set file name and location, and drag the mesh region or regions desired from the feature tree to the exported regions. Click File, Save all mesh exports. Thank you for watching. I hope this shows how easy it is to get started using BOXER to generate mesh for complex geometries. Please visit our website and contact us if you have any questions.